Hello YouTubers. This video is a small demo on how to set up IP address of your PLC in user program, by using function block FB55. You will find industrial Ethernet CPs, that support FB55 in the description. What are the benefits of this feature? The IP address can be changed at runtime, without loading hardware configuration into the CPU. There will be no need in using any special software, and user of such system will not be in need to know the programming of step 7. Your system becomes more flexible. So, IP address for PLC can be set by step 7, or configured by user program while S7 station is in run mode. Both of these variants cannot be mixed. You can use either configuration with step 7 or Viaduct user program. Principle of configuration via user program. To set IP address by user program, function block FB55, ipconfig, is used. By the help of the FB55, a configuration DB is sent to the communication processor at any time. All previous configuration data are overwritten by the new one. As soon as the user program transfer the data to the communication processor, the CPU switches CP to stop mode briefly. CP accepts the system data and applies and processes it during startup. Let's proceed with the configuration. First of all, create a new project and insert S7300 station. Insert corresponding CP. Open hardware configuration, open properties of your CP, and switch to IP configuration tab. Here you can find all the IP address setting possibilities. You can set IP address directly with step 7, or can select option, obtain IP address from DHCP server, set IP address in user program, or using other different method. This time we are going to use method, set IP address in user program. Select this option, click OK, compile your hardware configuration but do not load it to the CPU for now. To set IP address in user program, we are going to use Siemens function block FB55, ipconfig. This function block sends configuration data block to the communication processor. Let's observe the structure of the data block. The structure of the data block consists of data block identification variable and system data. Data block identification is a word type, and its value has to be 1. System data consists of type, ID, count of subblocks, and structure of subblocks. Type is identification for connection type, and its value for system data should be 0. ID is connection ID, for system data it should be 0. There are 3 subblocks. 1 for IPv4 local IP address. It's an IP address that will be assigned to the communication processor. Another one is for subnet mask. And last one is for default router. Subblock IP contains its ID, which value is 1. Length should be 8, as there are 4 bytes for IP address and 4 bytes for the header. IP address is divided into 4 parts, each of 1 byte. Sub-block mask contains its ID, which value is 2. Length should be 8, as there are 4 bytes for subnet mask and 4 bytes for header. Subnet mask is divided into 4 parts, each of 1 byte. Last sub-block is for router. ID is 8, length is also 8, as it consists of 4 bytes of router IP address and 4 bytes of the header. An IP address is divided into 4 parts, each of 1 byte. In total there are 32 bytes. In my case, IP address of the PLC is 192.168.1.3, subnet mask is 255.255.255.0, and router will be my PC, which address is 192.168.1.1. If you are planning not to use the router, then set the IP of your CP here. Our data block prepared, let's move to the programming part. In my program, function block FB1 is used to call ipconfig function block FB55. Function block FB55 has 4 inputs and 4 outputs. I have saved some variables that will be assigned to the FB55 in the static fields of variable declaration table. First of inputs is act, and it is a type of bool. It initiates the job that sends the DB to the CP. If the FB is called with act equals 0, only the status codes done, error and status are updated. Second input is LADDR, module base address. When you configure the CP with Step 7 hardware configuration, the module base address is displayed in the configuration table. Specify this address here. Next one is configuration DB, its type is any. Here you need to specify the pointer to the starting address of the data in the configuration data block, and length in bytes. Len is integer type, here you need to set the length information for the connection data area in bytes. 4 outputs. Done, bool type, it indicates whether the configuration data area was completely transferred. Error, bool type, it indicates that execution was done either with error either without error. Status, contains status code of the execution. It's updated in conjunction with the new data received and status parameters. ext status, if an error occurs in the execution of a job, this parameter indicates which parameter was detected as the cause of the error in the configuration DB. This word type parameter is divided into 2 bytes, high byte contains index of the parameter field, and low byte contains index of the subfield within the parameter field. These 2 bytes helps to determine where the error occurred. Depending on the size of your configuration data block, the data may be transferred to the CP in several segments. It means that FB must continue to be called until it signals that transfer is completed. This signal is coded into the output done. How does it work? You must upload configuration DB with data. Set the act to true, and keep it true until job is done. CP is supplied with system data. After job is done, output done is activated, and you can reset the act input. Please keep in mind that configuration must be downloaded each time after power loss. If your job is finished without errors, then your status code will be 8181 in hex. Otherwise you will get an error code in status, and ext status will contain more detailed information what caused the error. I do call FB1 in main cycle block OB1. Here you can see the call of FB1 with corresponding data block. To ensure that configuration data will be sent upon the loss of power, I do use organization block OB100, complete restart. On the startup, a memory bit is set here, and later it will enable the execution of the FB55. And I do reset that bit on the first cycle of the OB1. Let's try our application. At first, we need to ensure that configuration data block contains the correct values. After all the necessary blocks are downloaded to the CPU, you can download hardware configuration. CPU is in stop mode, transfer of the data block with configuration data is in progress. Communication is lost, CP adopts new settings. CP restarted, connection is established. Let's try to change the IP address by the help of the user program. We need to find a free IP address. IP 192.168.1.4 is free, let's use this one. As you can see, the IP address has been changed. We are in need to change the connection parameters in the OP, as connection with the old address is lost. Connection is re-established with the new address. Let's try to change the IP address again. And again, connection is re-established with the new address. If the video helped you, please do not forget to like it, and subscribe to the channel. Thank you for watching and happy coding.